Magandang araw po sa lahat. Ako po si Princess Rochelle C. Torquator, BSEE 2A. Ang topic na i-discuss ko po ngayon is the Poisson Distribution. Ang i-report ko po ay may 4 na parts, ang definition, graph, formula, saka konting examples. So, ang Poisson Distribution ay ipinangalan sa French mathematician na si Simeon Denis Poisson. Yun daw pagka-bigkas dun Simeon Denis Poisson. The Poisson distribution applies in its own right where the possible number of discrete occurrences is much larger than the average number of occurrences in a given interval of time or space. The number of possible occurrences is often not known exactly. The outcomes must occur randomly, that is completely by chance, and the probability of occurrence must not be affected by whether or not the outcomes occurred previously, so the occurrences are independent. So, what is Poisson distribution? Poisson distribution is a limiting form of the binomial distribution in which n, the number of trials, becomes very large, and p, the probability of success of the event is very small. So, dito sa graph na to, ayan nga, yung n ay dumadami, pero yung p, yung probability na magsasucess yung event is bumababa. So, habang dumadami yung n, bumababa naman yung probability ng success ng isang event. So, pwede, tapos, ang maibibigay ko dito na example is yung thunderstorm. Kunwari ngayon may 5 thunderstorm. Bukas maaari na mas marami or mas konti, pwedeng 3 lang. Tapos sa isang araw naman pwedeng dumami maging 6, ganon. Tapos pwede rin yung sa isang intersection, sa isang taon merong kunwari 1,000 na accident dun sa isang intersection. Tapos, pwedeng the next year, bumaba or magtaas yung mean average ng accident dun sa intersection. So, the Poisson distribution, the probability of, ito naman yung yung formula. The probability of exactly r occurrences in a fixed interval of time or space under particular conditions is given by the probability of r equals r, where r is the number of occurrences in a fixed interval of time or space. Ayan. Tapos, yun namang gamma is the mean rate of occurrences per unit time or space. So, bakit per unit time or space? Diba? Sabi ko kanina dun sa example, kunwari, yung sinabi ko na per year or per month, pwedeng per hour, per second, yung ganun. Tapos, pwede rin namang per space, yung sa per kilometer. Pwedeng yung example dun yun is yung sa traffic, gaano kahaba yung traffic jam sa sentro. Kunwari, sa Lunes, 1 kilometer yung traffic. Sa Martes, 800 meters na lang. Tapos yung t naman is the interval of time or space in which the events occur. Tapos yung i naman is the base of natural logarithms. Yun ay constant, which is 2.71828 or 2.72. Tapos yung dito, yung black na peak, parang pareho lang naman yan itong isa. Parang pareho lang naman sila. Ito yung galing kasi yan sa EDA book. Ito parang report ito na nakita ko na parang mas madaling i-explain. Tapos the Poisson distribution occurs when we count the number of occurrences of given event over a given time period or length or area or volume. Tapos may mga example pa dito. Galing rin to sa EDA book. The number of flaws in a square yard of fabric. Ayun, pwedeng sa isang square yard may ilang mga limang flows. Tapos sa sunod na square yard naman, mga 4 na lang, ganon. Tapos yun namang the number of bacterial colonies in cubic centimeter of water, ganon lang din. Tapos the number of times a machine fails in a course of a workday. So yung mga example baga ay hindi parang constant, parang may mean average, pero maaring magdami dun sa mean average or magkonti. Parang ganun nga. Tapos sabi, consider the development of a probabilistic model for the number of accidents occurring at a particular highway intersection over a period of a week. We can think of the time interval as being split up into n subintervals such that p probability of one accident in a subinterval is equal to p. Tapos p no accidents in a subinterval is equals to 1 minus p. Note that we are assuming that the same value of p holds for all subintervals, and the probability of more than one accident in one subinterval is 0. If the occurrence of accidents can be regarded as independent from one subinterval to another, then the total number of accidents in the time period, which is equals to the total number of subintervals containing one accident, will have a binomial distribution. The Poisson distribution is defined by one parameter, namely gamma. The expected value of binomial distribution is NP, where expected value of the Poisson distribution is gamma. In order to keep the mean in the binomial case constant at Poisson mean, it is reasonable to assume that n increases should decrease with NP minus gamma, that is P is equals to gamma over n. Tapos nakalagay dun sa the book. Figure 5.10, itong nasa taas, shows how the choices of gamma affect the shape of Poisson probability. Note that probability function is very asymmetric for gamma is equal to 1. Yun nga, nasa unang picture, yun nasa taas. Very asymmetric daw. Tapos, dito naman sa dalawang nasa baba, becomes fairly symmetric and mound-shaped as gamma increases. So, we can intuitively determine what the mean and the variance of Poisson distribution should be, recalling the mean and variance of binomial distribution and the relationship between two distributions. A binomial distribution has mean NP and variance. Now, if n gets large, the p remains at NP is equals to gamma. The variance NP is equals to. In fact, the Poisson distribution does have both mean and variance equal to gamma. The mean of Poisson distribution is easily derived using the Taylor series expansion of E, namely, to find the variance, find EY squared minus EY, open, y minus 1, close parenthesis, plus EY. Then derive the variance using similar arguments in expected value and the relation. So, ito na yung example para mas maintindihan natin yung, madali lang naman yung Poisson distribution. So, nilagay ko na rin yung sa taas, yung formula. Ang problem ay, the number of meteors found by a radar system in any 30-second interval under specified conditions averages 1.81. Assume that the meteors appear randomly and independently. So, dun sa, assume meteors appear randomly and independently, dun natin masasabi na, Poisson distribution siya. Ang tanong ay, what is the probability that no meteors are found in 1 minute interval? So, una natin kunin ay yung mean rate or yung yung gamma natin is equals to 1.81, sabi. Under specimen. Tapos, 30-second interval. Tapos, kung i-express naman natin yun into, minutes, magiging 3.62 meters per minute. Tapos, yung given time interval naman natin is, ano ba? No meteors found in 1 minute interval. Yung given time is 1 minute. So, sa Poisson distribution, self-substitute lang yung mga given dun sa mismong formula. So, yung gamma, papalitan mo lang ng 3.62. Tapos, yung time naman, palitan mo ng 1. Tapos, yung R naman natin is 0 kasi no meteors found in 1 minute interval. So, 0. Tapos, yung sagot is 0.0268. Tapos, may isa pang example. Ganun din yung problem pero iba yung tanong. What is the probability of observing at least 5 but not more than 8 meteors in 2 minutes of observation? So, nagbago dito yung time. 2 minutes na, hindi na 1 minute. Ganun pa rin naman yung mean rate, 3.62. So, ang gagawin lang ay papalitan lang yung R. R lang yung nagbago sa yung time. So, sabi dito, at least 5 but not more than 8. So, 5 to 8 yung gagawin natin na probability. Sa una, 5, papalitan mo lang. Ayun, palit-palit lang ng value, 5 to 8. Or, ang sagot dun ay 0.5451. Tapos, pwede rin naman, i-input sa calculator yung summation or sigma, yung, from 5 to 8, tapos papalitan mo lang rin yung formula nung mga given. Ganun lang. Tapos pareho lang rin yung sagot, 0.5451. Ayun lang. Tapos may quote tayo sa huli na, your best quote that reflects your approach is one small step for man, one giant leap for mankind, sabi ni Neil Armstrong. Yun lang po at maraming salamat. Saka pala maiintindihan natin yung Poisson distribution. Yung sabi ko nga kanina na nag-o-occur or pwedeng magamit yung Poisson distribution kapag nag-o-occur ang isang event randomly and independently. Ayun lang po at marami pong salamat. Yay! Thanks!